everyone. Today we're looking at some questions on Boltzmann distribution. So for this question here, we've got 6 marks, and it says the rate of reaction is increased by using a catalyst. Using the Boltzmann distribution model, explain why the rate of reaction is increased in the presence of a catalyst, and suggest the benefits of using a catalyst for energy demand and environment. Okay, so for this, we're talking about rate of reaction is increasing because we have a catalyst. We want the benefits using the catalyst for energy demand and also the environment there. So we've got a few things we need to mention, and hence why we're given 6 marks to work this out. Now, we've been given space to draw Boltzmann distribution, so people tend to like these sort of questions. So we'll go ahead and I'll put a very badly drawn sketch of Boltzmann distribution there for you. So with this, we need to make sure we have axes labeled. Y-axis, number of molecules. X-axis, the energy. We have a curve there starting at the origin, and also making sure when we get to that higher energy that it's not touching the x-axis. It's an asymptote, so that means that curve will not touch the x-axis no matter how far you take it on. Now I've got a couple of labels on there as well. I've got the activation energy in there, so the EA, when there's no catalyst, to just as it is by itself. And then I've also shown what happens when we do add a catalyst. So you can see there clearly we have a greater number of molecules that has energy greater than or equal to the activation energy, so therefore we're going to get an increased rate of reaction. So there we are. So we've got explanation. So again, this is where you got your space underneath that, so you can write these down. More molecules, like I said before, energy greater than the activation energy. I can say greater area, under the curve. Now, going into the energy demand, so we're taking care of that first bit, saying, why the rate of reaction is increasing. We've done that. Now, the energy demand, well, if we can add in a catalyst, and now remember what a catalyst does, it increases the rate of the reaction. So it increases the forward and also the reverse reaction. But if we can increase that rate, then we can decrease the temperature, which is ideal, because if we look here, we're shown a bit of information which helps explain this a little bit. So that's saying that the forward reaction is endothermic, has a positive value. So that means for this reaction, if we increase the temperature, the equilibrium will shift to the right hand side towards the products, which is great. That's what you want, because we need that hydrogen to be manufactured from this. So we want to increase temperature, but the problem with increasing temperature is that it could be expensive to do so. So we can add in a catalyst to speed it up. We can then lower the temperature, save ourselves some money, which is ideal. Now, in terms of the environment, again, it's just the benefit using the catalyst for energy demand. Done that. Now the environment. Again, we want to reduce the amount of CO2. Now, I don't have to go into explaining as to, obviously why this is going on. So you don't need to mention global warming. We're just saying that we can reduce the amount that we're using, the materials that we're using, so the fossil fuels that we have to use, so methane, for example. Hopefully we can reduce the amount of that we use. And again, maybe possibly talking about different reactions with a better atom economy or less waste, something along those lines that's going to help the environment in some way. Okay, so those are 3 aspects of it in which to get all 6 marks. If we got something along those lines, then we should be okay. Okay, and that will do us today for questions on Boltzmann distribution. See you next time.